see, are we live? Yes, we are. Oh, can't see me, but we are live. All right, good morning, good morning. So today we're going to get right into a security plan, a draft security plan to pretty much, it's going to be a lot less, fun. This is going to be the paperwork side of the practical. We have to basically go through and document the requirements that we're about to implement, right? So last week we talked about we're going to have a site that has a lab in it, and that lab is going to have a few teams that are going to be little analyst people that are doing stuff on the virus work, right? And there's going to be a headquarters location that has some admin folks and an owner or some sort of leadership or something like that. And then there's going to be a collections team that's going to be going all over the place collecting stuff, and it's going to have to remote back into our system, right? So just thinking about that, we have to figure out, how do we build that out? Now, ideally, you would have some sort of engineering team or system administration team that can architect this stuff for you and then just hand you the blueprints and hand you all the stuff that's about to be implemented. But of course, that's not what we do here with the practical side of things. Let's think about this. How would we have to build it? We should know the components that could potentially come into play. Now, obviously, there's 1,000,001 ways to do this. So there's no right answer here, and it all depends on so many different factors. And some of it we're going to do just because we want to make sure that we practice some of the stuff more so than how we would actually build it out. Because we're going to build it in such a way that the sites are they're going to be separate, right? And they're going to have their own physical devices. But in a lot of cases nowadays, it would be much better and more secure to just put your stuff on Amazon and call it a day. And so while I would go down that direction, I do want to just make sure that we've covered some of the hardware aspects that we don't see in the Amazon world or the cloud world. So, all right, so let's put on our list here. So first, let's just talk about the security plan. The security plan, you're going to have a whole bunch of different definitions for this, and you're going to see 1,000,000 different types of what this is. But ultimately, the security plan is your one-stop shop for all things cyber, right? And it's to be from beginning to end. So the beginning is kind of what we talked about last week about, well, what's the hardware, what's the software, what's the diagram, what are the ports and protocols, there's going to be that initial thing, what's the categorization, when we talked about the information types briefly. We're going to do all of those little things, and we're just going to kind of type it out in a way that is easy to see. So we're going to build this draft security plan essentially. Now, I'm not going to do all the nuances and the details, of course, as far as what all the people's roles are and stuff like that, but we'll see. Let's just kind of walk through how quickly we can really do this. A lot of times people get daunted by writing plans and stuff like that, but it doesn't have to be at all. And it's like you can get lost in all of this gobbledygook. So NIST is a great one-stop shop for all information security related, right? Just go there and there's templates for just about everything. Some of their templates don't quite always fully make sense. For example, I did security plan, Word template. And let's see, here's one of the templates that came up. And this template, here, I need to put that in Drive. And this template, is super basic. It has responsible people and all this stuff. It says include this, but it doesn't really give you how to include it or anything like that. So, but that's what we're going to use. We're just going to go ahead and start typing it in here and filling out basic things that you would normally need in a security plan. Let's see. And this document is kind of like the guide for how to build it. So if you're ever confused, you literally can just go to this. So for the people who don't want to get in there and say they don't know how to do stuff, you got to stop that. You got to see that everything is out there. It's all there. You just have to take the time to go through it and look. But we're going to go through it really quick and just kind of get a gist. No, I don't want a tour. So let's just go ahead and, what is our system? We never named our system. Let's call our system virus killer. Yeah, doesn't have cool acronyms like everybody usually has with all these random systems. Hey, whatever. All right, so our virus killer system, and we'll just make the date whatever today is, 10-18. I think it's the 18th, right? Oh, what the heck? All right. So obviously we can do all types of, I don't want to spend too much time on these little trivial stuff. But if you had a whole bunch of different systems, obviously you could put identifiers and all this stuff. Now, something that they put right up front is system categorization. So we went over the categorization last week, but we didn't really fill out any form. We just kind of said, hey, here, our information type is like proprietary virus information, and do we want to care about anything else? And we really didn't actually categorize it, but so let's go ahead and do that right now. Let's say nist categorize information systems. We'll bring up one of these and we're just gonna fill out, let's go ahead and do the FIPS. We're just gonna quickly fill out a let me see if there's a FIPS 199 template. No, whatever, it's not that big of a document here. Okay, so here's all we want. Security categorization applied to invitation type. We want the information type, and then we want to identify its impact from a confidentiality, integrity, availability. So we are literally just going to go with our single one. Now, if you're confused about what our impact is going to be, it's super basic. We're just saying, hey, is it going to be a limited impact, a serious impact, or catastrophic impact? Yay, right? So what we kind of went with last week, I think, was confidentiality was going to be high, integrity was going to be moderate, and then availability was going to be low. But we could probably argue that confidentiality and integrity should be high, and availability should be low. All depends on what exactly we're doing, but whatever, we're just going to do that for now and call it a day. So in our document, we would say, and of course, everywhere you go, there's going to be slightly different ways to slightly different things that you could do with how to get to this. So we would say confidentiality, high, impact, moderate, and availability low. So that's literally how we would categorize. Now, most of the places that you go, or if you're doing this in more depth, you might want to identify out your information types. And actually, you know what, let me just go ahead and put that in here. I'm assuming that this is supposed to be just like the header, but we could put, maybe our own in the system environment or somewhere. Oh, here we go, document. Oh, look at that, they did it. Document CUI information type. So our information type is just going to be information types, and we'll say, can I do a sub bullet? There we go. Information types, virus, killer, proprietary, and we'll say confidentiality high, impact medium, can't type, availability low. We'll call it a day. So if we had multiple information types, we just keep putting them there. Now, again, if you're in a particular organization or something like that, you might have a lot more details on what you care about capturing at this stage. Like maybe there's special requirements that your organization is really keyed in on that you want to make sure is considered for your system. For example, what's a good example? Privacy information. If, for example, we were going to have a whole bunch of privacy, let's say we did human trials. Well, we did human trials with this virus stuff. We're going to probably want to protect whoever those people were that did the trials, their information. And so we would put in there, proprietary privacy information or something like that here. But we're not going to do that. And then also, not only this information type, but we could have overlays and things like that that says, hey, if you have privacy, we want to add special security controls and stuff like that. And that's where we get into, selecting what controls are going to be applicable. You would do this all at this stage between step 1 and step 2, obviously. How you document that in a security plan isn't always the best, because as you can see, so I'm going to just scroll down here, they literally list out security controls, right? 1,000,001 security controls. And that's a super basic way to do it. And there's nothing wrong with that, but if you really go down this path, there's several hundred. And so we're going to show you what those security controls look like in a minute, but let's just call it a day for now. We're just going to use that as the information type. System environment. So what is our topology going to look like? We didn't really get into exactly what it's going to look like, aside from, hey, we have sites, we have users, we have random rovers. Let's do draw IO. Draw IO. So this is a neat little site that kind of does flowcharts for you, which I think is really cool. And we're just going to save it to Google Drive. Okay. File, new. And we'll do a blank diagram. Create. So literally, this is the same as Visio pretty much. So that's another thing that I get all the time is people don't, quote, know how to make a diagram, make a system architecture diagram. And so it's like super general, it's super basic, and it depends on how detailed you want to get. Of course, there's 1,000,001 ways to do this, and some people are much more specific about it than others. Some groups are different, but the gist is that you want to find out, or you want to capture, what is your accreditation boundary, in that what is the devices and the things that you are responsible for versus everybody else. And then in conjunction with that, what is my general attack surface going to look like? So if you can kind of capture that in a single diagram, that's what this is ultimately going to be. if you're going to go down the system, I mean the systems engineering route, I guess this would be kind of it'd probably be more of a SV1 maybe, or something like that, with a little bit of details, some sort of mix between SV1 and OV. I don't remember all the little nuances for those engineering folks, but you guys should know that based on what we do here. So let's just draw out first let me see here. We'll just start with our sites. So let's say server. All right, so we know that we're gonna want, I'm just gonna put a server at least one site. So we know that, well, let's, you know what, before I draw this out, let me go, well, let's just, let me just make some cloud bubbles here. Cloud. We have our internet. And then we're just gonna draw, let's just draw some site squares, I guess. I don't know exactly how do you draw here. Or would this be, okay. So yeah, so I'm gonna just make site 1, site 2, and then this is gonna be like a random users or something like that. So, and obviously they're gonna have to be connected by something, right? And each connection is gonna have certain ports open potentially. So that's kind of what we're gonna be capturing between here. And that's where the attack surface type stuff comes into play, is when site 1 talks to site 2, how is it doing that? Or when site 2 talks to, or when the rovers talk to site 1, how are they doing that? If they want to get out to the internet, how are they doing that? If the public wants to come in to our public web server, how are they doing that, right? So that's kind of the gist of where we want to build, or how we want to build. Is this seriously? That's weird. Squares have to be squares in this thing. Rectangles have to be rectangles. Anyway, so I'm just gonna create, all right, anyway. Okay, so before I fill this out, we'll just say that, hey, these are, here, let me just do rovers, collection team. And then, okay. And then we'll do site 1, and then we'll do site 2, or HQ site. All right. Okay. So that's obviously super basic what we're going to be going through. Now we can take this a step further and get into the ISPs that we're going to be using at each site, because our router or our devices are going to connect to something to get us to the internet. We're not going to be, usually not going to be connecting to the internet ourselves, but we could, obviously, if we really wanted to get into a lot of expenses and somehow buy our own infrastructure. I don't even know how you would do that, but I guess that's technically possible, maybe. Or you could build your own and not even connect to the internet and do all types of other weird stuff. You could go through SATCOMs, you could do some, anyway, we're not going to get into all these weirdest, we're just going to go with the basics. But that's the quick lay of the land. Now, to really understand what we're going to have in our lay of the land, well, we need to kind of identify what in the heck are we going to need in our system set. Now, if you don't know where to even begin, you can just kind of start with the basics, right? We can just say, okay, well, we know that we're going to need PCs, right? Everybody, workstation, or how about laptop? We know that we're going to need a whole bunch of laptops. So we can either draw 15 laptops in here, or we can make one laptop and then say workstation 1, workstation 2, etc. down the list. Now, everybody is different again on exactly the best way to do this. Whether to list every single device here, or to just point this to another file and do it that way. And it's all depending on your organization and all what you want to do, but we'll just say user workstation. Now the problem with doing it this way is that if we're going to say that this is all one entity, or not one entity, but maybe one type, we have to make sure that whatever our baseline is going to be consistent. So even though we have user workstations, their software and stuff is probably going to be different than the administrator workstations, right? Administrators are probably going to have a little bit different stuff. They're not going to have the same tools that the administrator. I'll just do admin. Whatever. They're not going to have the same stuff, right? So even though it's trivial, sometimes making sure that whatever logical separations are there are kind of captured consistently everywhere is probably a good thing, just so that you can remember that, hey, if this gets compromised, it's going to be different than if this gets compromised. Ideally, right? Not necessarily, but if there's no different, then you can lump them all together. So we know we're going to need workstations. We also talked about we wanted to have some sort of website, a website to do for the public. And again, normally, if we are super high security, chances are we might want to just farm this out, right? We might just want to farm it out to some cloud entity. And so there's 1,000,001 ways to do that. And so this isn't necessarily, again, the right way, but we're going to build it ourselves. So this is going to be ours in this case. So this is going to be the DMZ. So it's going to be logically separated from the rest of the stuff, which means we're going to need, okay, well, how do you separate stuff? Well, Firewall, that's probably a decent way to separate stuff, right? So when you're thinking about all of these things, try not to think of it as a bunch of complicated stuff. Just do it literally one thing at a time. How would you think about what you would need here, right? Okay, so we have a web server, we have our firewall, we have a few workstations. Let's say, okay, well, we need workstations out here in this random collections. In this random collections team, and we're going to need workstations over here in the headquarters site. All right. Now, how do these workstations talk to each other? How do these workstations log in and whatnot? Obviously, if you're not a Windows admin or anything like that, you're going to be like, well, how do you link them together? I guess you can. There's some sort of software, whatever. Obviously, Microsoft has its own stuff, so we can say Windows Server. Or if we're not, well, I didn't mean to put that there, but if we weren't sure, we would literally just start researching, like, okay, Windows login server, something like that, right? And then, okay, maybe that wouldn't work. I'm just trying to get, how would somebody who doesn't know anything learn that? I guess you would have to solve individual problems one at a time. You would have to think to yourself, okay, these workstations need to talk, and ideally they might be all the same operating system. If they're not the same operating system, what is the way to get them to talk? And maybe that would prompt you to take a Windows Server class or a Microsoft Windows class, and then you can see, oh, okay, well, Microsoft uses this domain thing to connect everybody. And so it's like, all right, well, we need this domain server to connect everybody. So let's just, we'll put a domain server out here. And then we might want to say, oh, okay, well, do we want our servers in the same space as everything else? And maybe we realize that that's not the best idea. Maybe not. It all depends on what you're trying to do. But let's see if this, can I make a rectangle like, yeah, okay. So two back. So obviously, so I'm just going to caveat everything now, and that's just that this isn't going to be perfect security, okay? So, but we're going to get into a whole bunch of security controls that are kind of going to give us more information on what we're supposed to do. And that's kind of the idea here. Now, we're supposed to build this stuff out and have an idea before we perform our implementation. But when we don't fully know, maybe we don't know all the security requirements. Maybe we know we need a directory server, but maybe we don't know that it probably should be kind of separated from the rest of your space. Maybe not, right? So there's going to be security controls that we're going to go through, and that's going to make us put requirements on all of these systems, which is going to lead me to, well, how do you find those requirements? Where, like, maybe there's a security control that says logically separate your stuff, but maybe you need even more information. You're like, well, how do I do that? There's a site that the DOD actually publicly releases similar to NIST. And believe it or not, a lot of these government sites have a lot of public information about exactly how you do this, how do you secure your environment and stuff like that. And so this is what's called the DOD Cyber Exchange. So literally, if you had normally searched DOD Cyber Security requirements, okay, maybe it wouldn't come up just like that. Okay, STIG. So that would bring it up. So STIGs, Security Technical Implementation Guides, are exactly what I was just talking about. Is they're going to tell you, hey, if you have a Windows user workstation, how should you secure that thing? If you have a Windows Active Directory server, how should you secure that thing? And so you literally can go to this site publicly. Everybody can get to this, obviously. And just literally search and say, okay, let's see, Windows, and then say, okay, well, there's a whole bunch of Windows stuff here. Oh, look at here. We have Windows 2012, 2010. So we would literally download these things and load them when it's time for us to figure out, okay, what type of security do we want? And we would read these to figure out what in the heck do we need to do. So actually, let's just do Active Directory domain STIG. So we could literally download that, and I think I think so. I wasn't going to go through STIGs today because we're supposed to be just document stuff. So I'm not going to do that right now. But just know that that's what we're going to have to do. And so part of the security plan, actually, before we actually start implementing things, is we generally kind of figure out, okay, well, what type of security do we need, and what type of assessments do we have to do, or can we do, to show that we've implemented what we're supposed to implement. And so when we're going through all of this stuff, at the same time, we're going to try and figure out, okay, what are the security requirements for this? What are the security requirements for the web server? What's the security requirements for our firewall? And you just do that over and over and over again. So now, in our case, we're gonna basically put, let's go ahead and put a switch in here as well. Whatever. It's a weird way of doing it, but whatever. So we need a switch as well, because that's going to kind of connect all of our devices together in here. So we could kind of put it, there's a whole bunch of different ways we can do this, but whatever. I'm just going to kind of combine them together like this. And so, and we know, okay, well, these guys, they're not going to be operating with any firewall. They're probably going to be just connecting to any random network. So not necessarily devices that we own. So within our requirement here, it's not really going to be anything. They're just going to connect through some sort of ISP that is outside of their environment. We'll just make it outside like this. And so are we, at some point, we're going to be connecting to a outside entity. So let's go ahead and make them outside. And same with this guy. But at the same time, this guy actually does have a location. And so we probably are going to need the same thing here. I'm going to need like a little firewall and deal for this guy. Now, let's see. Now, again, there's a whole bunch of different constructs here, and the more secure, or the more secure we want to do, the more things that we can add in here, because something that, from a security perspective, we haven't even talked about is, well, how do I verify all this stuff is clean? Is there some sort of tools that we should use? And it's like, okay, yeah, there's probably some sort of security tools that we might want. Security, server, whatever. All right. And so it's like, all right, well, we have our security, we have an AD, we have kind of like the basics, we have a web server. There's probably going to be some sort of collaborative server that we want to use as well, potentially. I hate this. I don't like the way they do these squares, but whatever. So let's just make here a collab. Okay. And then again, we get into security requirements, but the security server, maybe they want this even more separate than these, who knows? So we might need to consider that. But we also have to consider, okay, well, how are these guys connecting to this? Are they connecting? How are they getting through to this environment? Well, we're going to need some sort of device that can, I didn't mean to type that, but whatever, we can just use this. We're going to need some sort of device that can process our requests to get into this network, because this is a firewall, and it's like, okay, well, we could potentially configure this firewall to let these things in, but then how do we authenticate to that firewall? And so it depends on what devices you own and how you configure this, but ultimately there's going to be some sort of VPN server that you're going to need to pass through this. You can make it could be one device and it could be all part of the same thing, or it could be a separate device that then is authorized to pass through this firewall and connect to the rest of this stuff. So it all depends on how you set things up. And again, there's VPN security requirements, right? So we'll get into building all of this, and we're going to get into securing all of this and coming up with ways to either do it in a reasonable way or maybe we'll have to accept some risk. Maybe it's too difficult to do it exactly the way that security wants it. And that's where we're going to get into, okay, well, what is the bang for our buck? How long it's going to take? What is the resource requirements, and what is the overall actual likelihood, and all that other stuff that we had mentioned previously in, is it a major severity vulnerability? Is it really relevant? That can they get to it? And then if they can do all of those things, what happens if it happens? If they do compromise things, do we have things in place that can kind of counteract that? Is there the security server, is there some sort of monitoring going on that we can kind of see, which gets into another thing. We're going to have our own network. Well, we call this a security server, but we're probably going to have something more in line that would be some sort of intrusion detection, network intrusion detection device. Do they have IDS? Whatever. I'll just call it a. I don't know. Whatever. I'll just make another server for now and call it. Oops. We'll kind of play with how this looks and another thing. Let's just say IDS there, and we're going to have something that's going to monitor all that stuff. And now we can kind of say, okay, well, we know that these guys are connecting to each other, but is there an easy way to draw a, how do I draw a, oh, look at that. So we know that, let's see. How come I did that for this one, but not for the other one? I don't know. All right. Whatever. There's all types of ways to do this, but we'll just try and make this look like it's going through that firewall. Bring to front. All right. Okay. And I guess we can bring our firewall down here. Whatever. Doesn't really matter. I mean, it does, but it's not that serious. We can kind of finagle this stuff as necessary to make it look right. But the point is, we have stuff going into here. We have stuff going into here. And it's technically going through the internet to do it. Something I forgot to. It's going through the internet to do it. So we know that that's kind of how things are going to get to this. Now, so there's a few different things. One is we have traffic going to the internet because it just wants to browse the internet. Maybe you want to just go download stuff or look at things that in your day-to-day work or whatever, right? And so we have various ports that we would need to, let's say, ports. And so ideally, we would define, and we could define it with different color lines. That's what a lot of places do. They'll use a different color line. Just for the sake of time, I'm not going to try and make it all pretty, but let's just say that we have a VPN port, and everybody uses different ports for this stuff, and there are security things that some people like to obfuscate the port used and say, okay, well, if we have an open port here, let's use something that's non-traditional so that if somebody tries to scan us, it'll take longer and maybe we'll be able to find them before they really figure out what port we're using for whatever, assuming that they're not seeing our actual traffic and stuff like that. But for the sake of this, again, we're just going to say out. And something else that we always get into is outbound, inbound. There's always a lot of confusion about that for various reasons, but how do you make this left justified? I hate that it's right justified. Little things like this are gonna kill me. Anyway, so when it comes to outbound, inbound, you're going to see it flipped in some cases. Like on some devices, you'll see source, destination, and those aren't correlated directly to outbound and inbound, right? It's because it's just saying, hey, where did this traffic come from? And so when you say source, destination, it has nothing to do with which direction it is. So really, when we talk outbound, inbound, normally we're talking in terms of what is it that we want to protect. And so an outbound port, let's just say outbound port, is saying with respects to what we want to protect, the ports that are allowed to go out, which is I'm at home or I'm at work and I want to query the internet, well, we know that that's port 80, port 443, right? And then we say, okay, well, to also query the internet, well, we need to be able to find what these things are. Google.com is DNS, so we need 53 for a DNS entry, right? And there could be a whole bunch of other possibilities depending on what we have. Like, we didn't talk about mail at all, but somebody's going to need to have some sort of mail server, right? So we're probably going to need to have that. Again, in the real world, a lot of small companies aren't going to set up their own mail server, right? They're going to just have whatever. What is that? What are those hosting, all the different hosting sites that are out there? Maybe Amazon, maybe GoDaddy, whatever. And actually the mail server is probably going to have to be in the DMZ, because everybody's going to have to be able to see that to process stuff. So those are little things that, excuse me. Oops. So those are things that we're going to have to just kind of consider with all of this stuff. So what are the mail ports? Well, I don't remember all of them, but let's just say 993 and 465, I think, something like that. So that's like IMAP, and this is like SMTP, I think. Let's just do SMTP port. Yeah, 465 for the secured dealie. So that's our outbound ports for this particular site. And most likely for these, we're not going to oh, actually that's not outbound, these two are inbound, my bad. So let's just do inbound ports. Again, with respect to our site inbound ports, we know we need 993 for IMAP and 465, and some and this gets into, if you're not sure, you would have to figure it out, right? Like, you'd have to listen for traffic, and you'd say, okay, well, what is it that each one of these, and you'd have to look up the defaults, figure out what defaults everything is using, and go from there. But generally speaking, the mail server is going to need either 443 if you're going to be doing a general exchange or something like that. You're going to need DNS. There's ways you don't have to have an inbound DNS, but for whatever reason, I want to say some DNS needs an inbound connection as well, something like that. And obviously, again, this is just for quickly, obviously, we would do this much more officially, and we try and basically look these things up and make sure for 100% fact that this is all that's needed. Now, same with these, the outbound ports 80, 443, 53 should be good to go on this. Now, a lot of and we don't even need any inbound points. Like this should never, nobody should ever be directly allowed into this. Now, this gets into the confusion a lot of people have is, well, obviously, if we're talking to the internet, stuff's coming in, right? And it's like, yep, it's coming in, but because it's TCP, it's an established connection. And this is probably why, for example, 53 inbound, it's not an established necessarily. I don't know how UDP exactly works from an established perspective is, but I don't think you can. Don't quote me on that. I'm not 100% sure, but basically for established connections, you can dictate, hey, I want things to go out, and the only things that can come in are things that are established connections. So if I've made an outbound request, established a connection to whatever I'm requesting to, now whatever comes back in is allowed, because it's based off of an outbound established rule. And you'll find that when you have these connections like this, it'll go outbound 80, but the inbound port is just going to be dynamic. It's going to be some random port that's that is created by the OS that says, okay, yep, you just use whatever port you want in a particular range. And so it's not really as crucial. What else? Oh, so one more thing so we have outbound ports here, same deal. Again, nobody should need to go in that. So we shouldn't, just think about your home network. At least assuming that you don't have weird camera devices and stuff that you want to be able to log into from some remote place. At home, you literally have no reason to have any access inbound to your system, meaning you shouldn't have stuff listening at your house for connections from the internet, unless you are doing it on purpose. Of course, you're hosting a server, you're doing something weird, then you can do that. But generally speaking, most day-to-day people, they don't need anything inbound, and that's the same with these teams. Rover teams, they're not going to need an inbound connection to anything. HQ team, they're not going to need an inbound connection to anything, and that's just going to add a layer of protection if you don't do that or don't try and allow something. You'll find that most places don't even they'll block all for inbound and then allow all for outbound, which is okay-ish, I guess, but that's assuming that whatever your devices are completely secure and trusted, and obviously somebody's going to hack your stuff at some point, unfortunately. And so at the very least, if you're blocking all of the random ports, it's going to try and communicate on. It's going to just be one more layer of thing that it's going to have to do to make sure that it can do stuff. Is how important is that? I don't know. I think that's arguable, right? Like, if it can go out on 80, how is that any better than it going out on 180, right? Like, it doesn't, I don't know. I don't really know the full importance of that. I think that's definitely debatable, but practice-wise, might as well do it. Why not? And then at the very least, at least you can focus on certain traffic, and you don't have to see things differently. But I think you'll probably have to talk to a hacker to really know, because I feel like a lot of security practitioners that are doing this stuff, they can say what they think is right, but at the end of the day, I think the hackers are the ones that can really tell you, hey, doesn't really matter, or does, or whatever. And so, but hey, might as well do as much as you can, is I guess the bottom line. So there we go. So we have our ports, we have a basic environment that we think we can use, or that we'll basically need for this stuff, and we're going to have to set all of this stuff up. So all of this stuff that we just documented, we just drew, we're going to have to document in our security plan. And again, what time is it? How long has it been? Oh wow, it's already been 50 minutes. So I'm gonna just try and hurry up and just kind of get to a couple of the different sections just so that we can see where did it go. Here it goes. Okay, so we have our graphic. Let's just for kicks, I mean, obviously it's not done. We would label it. Let's go ahead and label it and say virus killer network boundary. Okay. And we could see sys ID 1. We can say whatever. Can I increase this? Yeah, let's see. All right. So there's our network. Can I zoom out? How do I view file? Let's just say export as PNG, export Google Drive, root folder, authorize. Oh my goodness. Okay, let's not do that. Let's just export to here. Okay, so we can literally just put that in our document here. I think it's gonna be smart. Yep, there we go. Call it a day, right? So that's it. We did our little diagram. Now, obviously there could be more and I probably missed something, but this is off the cuff, right? Now we'd say, okay, well, what's our hardware? What's our software? Well, we kind of, by drawing our diagram, at least we started to find out some of this stuff. We found out that we need all of these different servers. We have a whole bunch of workstations that we need. We know that we have some network devices that we need. And so we would literally, and I kind of wrote some of them down before this because I didn't want to spend too much time. But we would ultimately have a paste unlinked. We'd ultimately have a table of all the stuff. Now, ideally, let me see if I can add columns. Insert column right. Here, insert row above. We can say device name. We can say, so a lot of places they'll say firmware or something like that so that we're tracking on this. A lot of places will want, so this is kind of like an inventory construct, right? Serial number or something like that. If you have, a lot of places might have other requirements that you might want to put into play, like maybe if we look at this, maybe we want to know certain information about these boxes, like are these what OS is going to be on these boxes. So like we have firmware for the actual hardware, but then what is installed on top of that firmware, not always going to be the same thing. A lot of people get that mixed up, but it is what it is. So for example, actually, before we even get to there, let's just say hardware, make, and model, the basic inventory stuff, right? Make, model, whatever. And so these are, let's say we have some sort of Dell blah, blah, blah server, well, whatever, Dell 1234. And we have some special server on that hardware. We have a special serial number, let's just say, and then even though we know that we have a particular hardware firmware, the actual OS that's going to be installed on this, well, that's going to be Windows 2016. So sometimes it's good to just be able to see all of that information all in one location. Obviously, this is basic inventory 101. So again, when you start getting into how are you supposed to do this, just you're gonna have to go through the basics, go through Google, whatever you need, be smart about it, and that's it, right? Simple as that. So I'm not gonna fill all this out right now because I want to save time, but you get the gist. We would have a hardware list in here. Oh, look at that. They kind of tell you model, version, service pack, blah, blah, blah. And Yeah, so OS, a lot of times also, because naming conventions, purpose. Because of naming conventions and stuff, some people want to obfuscate everything. I think that there might be good possibilities to that, but it's so easy to tell what something is going to do. Like we had talked about these ports, right? So if I see a server, it could be called server 123, but I see 993 on the traffic to it. Well, I know it's a mail server. So I think that the naming of stuff, it could help, but it's like very, very fringe of how it helps. It's right before you get any information whatsoever. And so there's most proponents, I think, would disagree and say, hey, it's all critically important and whatnot. But I don't know. I think it's up for debate. So anyway, if you had cryptic names and you didn't really know what this stuff was, a purpose field would be much more appropriate, and you could just do, active directory server or whatever, blah, blah, blah. And then you would just fill all that out, right? Easy day. Now, software components is something that we did not really talk about much, but in the same vein, software is going to need to capture all this different stuff that we're going to want. So first of all, software we know is going to include, let's just, can I create a table here? Insert table. Let's just do this for now. Let's see, description, manufacturer, I guess. Let's just call it a day. So here's where we like say, okay, Windows 10, Windows 2016 server. We need a VPN. We said we needed a mail server. Software. I'm just gonna say that for now, because obviously we have to figure out what this stuff is going to be, what type of software we're going to use. Again, this gets into engineering and architect and the people who are actually going to be doing this, but if you have an idea, that helps, right? So we're going to just kind of figure out some of these things to use. I'm going to choose them myself, of course, of what to use for next week, but for now, let's just go that route. Cisco, let's just say we're going to have some Cisco switches and firewalls. So it's going to be Cisco iOS. What else? Security stuff. Let's say we're going to need a vulnerability scanner or something like that. Let's say we want some sort of host-based IDS or something like that. What else do we got? We need a collaboration software, collab software. All right, so literally we would just go down the list and list all of the main components. Now, something that we often get messed up is that there's an infinite number of pieces of software, right? And this, I can't stand this when it comes to a lot of details, is sometimes these are kind of big pieces of software, right? Obviously, if you really think about it, anything, one executable is a piece of software, right? I could have one executable do a lot of damage just as easily as I could have these big conglomerates of tons of executables packaged into one do damage, right? And so if you really think about the software, well, there's thousands of executables on your device just for Windows alone. And so you can say, oh, well, that's part of the Windows software, and so that's fine, right? But at some point, you're going to have so much random software to get a job done that you can't inventory it all and track it reasonably if you don't be really smart about how you group things together. you know, for example, last week we installed like WordPress or something like that, right? And when you installed it, I don't know if anyone saw, but when you install things on Debian using the apps tool, you just see it'll tell you, hey, here's the packages that are going to get installed. And each installing one suite like Apache or WordPress or whatever is going to install 100 other packages. And then each one of those packages has 50 or 100 or however many different pieces of software in it to get some particular job done. That's no different than all of these other things, right? And so when you're doing inventory and when you're doing this stuff, you're going to need automated tools to do baselining and scanning. But at the very least, the package organizer, the thing that initiates the installs and the uninstalls, are kind of your best friend. Those are what we want to key in on, is what is the owning entity that prompted the install and can prompt the uninstall of all this stuff. And that's what you kind of want to capture here. And then another thing is, we could get down into so many weeds in this security plan that we end up having a software list that's 1,000 things long if we really get into all the nuances. So we just have to be very smart about it, be careful, and then just capture it in a way that it makes sense, and then let the automated scanning tools help identify holes in those little individual pieces. Like if I have this collaborative software, I might have some random DLL in there that's vulnerable. Well, we're not going to capture that as a separate software or anything like that. We wouldn't capture if you know, this collab software installed WinZip or some sort of zip thing for us, we wouldn't want to necessarily put WinZip separately, right? We would just kind of put it all together as part of the package, and then let these other tools help. So anyway, sorry, that probably was really long for something that wasn't a big deal. Is aimed and yeah, so yes, whatever, owned and maintained, whatever. You could put that as part of this. You could say, for example, external or externally assessed or something like that, or managed, and then you could just call it a day, yes, no, and call it a day, right? So you could handle that a few different things. And that's kind of the basics. So the last thing, I know we're already getting into over an hour, so I didn't want to go too far in this, but the last thing we would do is, so now that we have our hardware, we have our software, we have our diagram, we literally would, and we have our categorization, we would select our controls that we want to apply or that would be applicable, right? And so this is where this gets into play. It says, hey, this particular control, so this is a control limit, it's an access control, limit system access to authorized users, processing acting on behalf of authorized users, blah, blah, blah. And so this is saying, hey, do we think that did we already implement that? So if we got an existing system, we could ask ourselves, yeah, I think that's implemented. Or we could say, no, I don't think that's implemented. Or then we'd say, no, it's not applicable for whatever reason. Now we could go through this particular list, which is small compared to the actual list that's out there, but this is what we would normally do. So let's say, I think there's another nist, select controls, security controls. There is I want to say that there's a automatic form that can help you select download security controls. I hope there is. Could have sworn there was. Okay, well, I guess if there's not, we can kind of do it ourselves. Let me see. Search, that's might be, okay, here we go. All right, so if we say any, we say priority, we'll just leave that alone. Oh, that doesn't, damn it. Okay, well that sucks. Interesting. That's unfortunate. Okay, so I'm not gonna go too crazy in here. There are sites that will allow you to download nist download security controls. Excel. Oops. Here, no, yeah, see, there's all these other sites that'll have you do that. I was hoping that there would be a NIST specific one. Word version, blah, blah, blah. PDF. Come on, guys, seriously?
I'm going to sleep now.
That's extremely annoying. So I'm not going to do that right now because I don't want to give you a random site that probably is weird or whatever. But so here, what I was trying to do is when we say that we have high confidentiality, moderate integrity, low availability, the idea was that we can see how this is going here. So access control, AC1 is a security control that is applicable to low, moderate, and high. And so if you have an information type that's low, for example, this information flow enforcement, if your stuff was low, well, this wouldn't be applicable, right? And so that's kind of how we break things down. And if you get into this, there's some things that they're not even applicable by default. It's just something that you would add if you think that, you know, if you had an overlay or something that says, hey, you know, I really want to make sure we have data mining protection, whatever, then we would just have an overlay and it's not applicable in their baseline to a low, moderate, or high system. And so there's tools out there that you can, based on whatever you say that your system is, it will download this into an Excel spreadsheet. That Excel spreadsheet ultimately becomes this. And we would say, okay, for each one of those items, we would say whether it's going to be implemented or it's not applicable, or we're just not going to do it, which they don't have here, but maybe we're not going to do it, which is another annoyance of mine. But anyway, so that's the gist. That's all I got for now. So what we'll have for the next week is we're going to export this stuff out into an Excel file so that we can go through and show how we would identify what's implemented and not, and then start to plan our implementation for how we would kind of go through those and then build out some of the systems that we've identified as issues. And so it's going to be quite a bit of stuff. Like the implement process, we're literally going to have to build all of these servers. We're going to have to securely configure them. Oh, that's something that we didn't. So I would normally also have one more section here, and I would call this, like I would change this section to security assessment. Now we could actually add another column here and say security assessment here, but that's not necessarily going to give the details that we want with, okay, hey, well, we're gonna run some sort of vulnerability scan on everything. We're going to apply a manual STIG that we had talked about here to this stuff. We're going to apply those controls, and then what maybe we have instead of a STIG, maybe there's like for this, maybe there's no STIG, but there's security guidance, and so we can put that security guidance document in there, and then we're going to literally go through and assess those things after we implement it. So that can come at various stages. It can come after we've made this implementation plan and figured out what controls we want, but it's all the same. So I mean, I can put this before or after that, but since this is such a huge document, you know, I would probably just attach a new plan for that, like an appendix or something for this. Anyway, so that security plan is literally just going to identify, hey, what STIGs, what security stuff are we going to do to show that we've assessed that this stuff is or is not good, and we've assessed our holes, and then came up with a whole bunch of different vulnerabilities that we need to track and be aware of. Anyway, that is all for now. Thanks for watching. Hopefully that wasn't too boring, and but this is literally how you would do your step 1, step 2 stuff, and then get into step 3 in the implementation side of things, which we will do. I think we're going to start that next week, but I don't know. More to come. Let me know if you have any questions, comments, and thanks for watching. Out.